my fellow mathematician of applied maths. Welcome to the numerical analysis for scientists and engineers. We are looking at the finite difference, finite difference, and today we are considering the algebra of finite difference operator. Here you are going to prove that when you are given this finite difference operator of f of x, g of x, it is equivalent to f of x plus h multiplied by the operator of g of x plus g of x, the operator of f of x. So to do that, we begin by noting that the operator of f of x and g of x can be written as f of x plus h multiplied by g of x plus h minus g of x f of x. Here h is a constant away from x, a fixed distance away from x. We can subtract f of x plus h, g of x, and at the same time and the same. When we subtract f of x plus h multiplied by g of x plus f of x plus h multiplied by g of x, we don't affect our equation here because subtracting and adding, the result is 0. Then from there, we can factor f of x plus h because it is common. We factor it in this first two here. We factor this value here, this one. We factor this part here and this other part here. We factor it outside. And when you do that, here we shall be left with the g of x plus h minus, here we shall be left with the g of x plus. In the last part here, we have f of x plus h multiplied by g of x minus g of x multiplied by f of x. So in the other part, we can comfortably factor out g of x so that we shall be left with f of x plus h minus f of x. Now clearly, you can see this part here, it is one difference of g of x. This part here represent all this section here, this one up to here represent g of x. It represents g of x, and the last part, this one, represent f of x. That is the one difference operator. And of course, this is the end of the proof of what we are required to do. So you are required to show that the left hand side is equal to the right hand side. So we have begun by writing the left hand side in terms of one difference, first one difference operator as indicated here. Then we have simply introduced f of x plus h multiplied by g of x plus f of x plus h multiplied by g of x. And when you subtract and add the same constant, the result is the same. Then we have found the first up to here. Remember, we have factored f of x plus h to be left with g of x plus h minus g of x plus the last part we have factored f of x plus h, which is common, and we have been left with g of x into bracket f of x plus h minus f of x. Then we have seen that whatever is here in this square bracket, this part, it is the first one difference of g of x multiplied by f of x plus h. Then whatever is in this square bracket of the last term, f of x plus h minus f of x, it is first one difference of f of x. And that is the end of proof. Thanks so much for taking your time to study with me on the algebra of one difference operator. On how to study such kind of learning about numerical analysis, kindly tune on to my YouTube channel so that you don't miss a single video which I upload for us now and then. Remember also to subscribe to the channel so that you'll be notified whenever there is a new release. May I also hear the comment from the description box below. Bye bye. See you in the next presentation, and thanks so much for watching.